this clip, let's create a simple prototype of a shopping cart for groceries. The web app should look like this. It's a simple HTML table with a header that has product name, photo, and quantity. The table body has 3 products: cheese, bananas, and milk. The HTML code for this table has the following 3 parts. First, the table HTML tag that contains the whole table. Second, the t-head tag contains the table header with product, photo, and quantity. Third, the t-body tag contains the table body with details about the 3 products. Inside the table header, there is one tr or table row element with the expected 3 header cells for product, photo, and quantity. The table body has 3 table row elements. The first table row has 3 table data cells with cheese, an image child element, and 1 for quantity. The second table row has a very similar structure with 3 data cells for bananas. Same goes for the last row with details about milk. We are going to write Elm code to display this HTML table. Notice that a table is a collection of data. Data on columns has the same type, for example, string for products and integer for quantities. In contrast, data on rows uses the same mix of different types of data: string for product, string for photo source, and integer for quantity. Let's see some examples of Elm collections that can store such data. Some collections store the same types of values, such as values in a column from the previous table. Lists and arrays require that all items have the same type. Mixing types is not allowed. Lists are delimited with square brackets and the items are separated by commas. Notice that elements in each list have the same type: integer for the first list, string for the second list. Lists support various typical operations such as mapping and filtering items. However, items in a list cannot be accessed by index. Lists are very popular and widely used. Arrays are also collections of items with the same type. Typically, arrays are created from lists using the ArrayFromList function and the list as a parameter. Just like lists, arrays also support various operations. The major difference is that items in an array can be accessed by index. For scenarios in which it's very important to access items by index, arrays are the right choice. Otherwise, arrays are less popular than lists. Records and tuples accept items of various types. Records use curly brackets as delimiters. Items in records are separated by commas, just like items in lists. Records are collections of named values or key value pairs. In the above example, the name field has the John string and the age field has the number 9. Since records accept different types of values, they are very flexible and widely used. Records are somehow similar to JavaScript objects. However, records have no concept of inheritance. Tuples are a simplified version of records. Tuples use brackets as delimiters, values are separated by commas, and names are not used. Basically, tuples are collections of values with different types and no names. While records are flexible and can have many items, tuples can have maximum 3 items. A typical scenario for using tuples is to return multiple values when calling a function. Let's have a quick demo and add a table with a shopping cart to the web app. We are going to use those table-specific tags such as t-head, t-body, and so on. On the demo machine, switch to Visual Studio Code. In preparation for this demo, I already added 3 image files for bananas, cheese, and milk. Let's add the new table as an extra child node to the outer div. Comma, table, press enter to auto-import the table function, then 2 empty lists as arguments. Let's add the table head and table body as child nodes, which means adding them to the second list. Type t-head, press enter to auto-import, and 2 empty lists, comma, and same for t-body. Enter and 2 empty lists. Press Ctrl S to save and auto-format the file. Looks good? So let's add the table row for the header, just like in the previous slide. The table row is a child node of table head, auto-import. It has 3 child nodes, starting with the product text. The next two notes are very similar, so I'm going to copy this, add a comma and paste it twice. Then replace product with photo and quantity. Save the file. Now let's add the 3 rows in table body with product details. Start with the table row, which has 3 data cells. The first cell has the product name, auto import, text cheese. The second cell has a child node with the image tag. Auto import it, then use source as attribute to indicate the file name, cheese.png, and an empty list as the second argument since it has no child nodes. The third cell has the quantity of 1. Save the file. There are 2 more table rows. Let's copy the first row, add a comma, paste it, add a comma and paste it again. Now update the 2 rows to match the table. Bananas, bananas.png, quantity is 3. Finally, milk, milk.png, and quantity is 2. Save the file, no errors. Let's check it in the browser. Refresh the page. Notice that the cheese is too large. Let's make all images smaller. In the image attributes list, add width set to 100, copy and paste it to each image. Save, switch to the browser and refresh the page. Perfect! The shopping cart prototype is working as expected. We achieved a lot in this module. We started by looking into basic data types such as string and wrote our first Elm web app. Then we looked into operators such as arithmetic and appending strings. Conditions are implemented with if and case expressions which must return the same type for all possible branches. HTML tags have corresponding Elm functions which expect 2 lists as arguments. Finally, lists and arrays are collections of items with the same type. Records and tuples are collections of items that can have different types. Our web app evolved from just a greeting to a shopping cart prototype. Still, we used a lot of copy-paste. There is a lot of code repetition, and the shopping cart has no interactivity. Keep watching this course to see how to fix these issues. In the next module, we are going to add basic interactivity to the shopping cart and get rid of the code repetition.